All right, I'm conducting a little experiment here, and I'm going to try to teach you how to calculate z-scores and p-values and to find percentages and probabilities from normal distributions using our calculator. This was the process we did by hand this week, where we find a z-score and we can take that z-score to the table to get your p-value. But now we can use our calculator. It's quicker and it's actually more accurate. So we've got 6 different questions, all having to do with an example of a mean score on the math SAT is 500 with a standard deviation of 100. So I set up a little chart for each of these and put the mean of 500 and went out 3 standard deviations to the left and to the left and to the right. So the first question says, what percentile is represented by a score of 735? So 735 on our sheet, on our graph, is going to be like right about here. So what we're looking for, Z tells us how many standard deviations it is away, but we're not even really interested in that. We don't need that anymore. We can get the percentile, which is the area to the left of 735, using our calculator. So what you're going to do is you need the following information. You need your mean and you need your standard deviation. And on your calculator, they're going to use symbols for this. Your mean is mu and your standard deviation is sigma. So we're going to turn our calculators on, go to second vars, and we want choice 2, normal CDF. This gives us an option for a lower bound, and in this case we don't have a lower bound. We're just looking at less than 735. So this automatically gives us a lower bound of -1 times 10 to the 99th power. You could do -100, or you can leave it as that. But we do have an upper bound of 735. The only other information we need is our mu, our mean, which was 500. And our standard deviation, our sigma, which is 100. Hit enter, puts all your information in a little list for you, and there it is, calculates your p-value. So p is 0.9906, which means that there is it's the 99th percentile. 735 is in the 99th percentile, which means that 99% of scores were less than 735. So, example 2, we're looking for a problem where we have a lower bound and an upper bound. So we're looking for between 650 and 700. So we're looking at like from here, this area, right there. The percent of scores or the proportion of test takers to earn a score between 650 and 700. So we go back to second vars. Choice 2, normal CDF. What's nice is that some of our information we get to keep, like our mu and our sigma, but I want to change my lower and upper bound to be 650 for the lower bound and 700 for our upper bound. Enter, enter, enter. And you get 0.0441, which means that approximately 4.4% of the test takers scored in that little area there. Example 3. We want to look at now not an interval, but outside of an interval. So find the probability a test taker earns a score less than 400 or greater than 800. Now, this actually lies on a standard deviation. This is going to be x minus 1 standard deviation, and this is going to be x bar plus 3 standard deviations. So we could use the percentages that we know to figure this out, but we could also use our calculators. So what we want to do is we want to look at the interval from 400 to 800, and we want to find the probability that that does happen, that it's in that, and then you're going to subtract that from 1 to get your answer. So we're finding this probability, subtracting 1 to get that probability. So go back to second vars, choice 2. And our low bound is 400. Our upper bound is 800. Everything else is the same. And so we get a p-value for that interval within 400 to 800 as 0.8400, if I round it correctly, I believe. And so what we do then is we're just going to subtract that from 1 minus 0.84. And so we get 0.1600. So 16%, or you have a probability, 16% probability of scoring less than 400 or greater than 800. Okay, next question. What is the probability of a test score differing from the mean by less than 50 points? So we want to know what is in this interval here between 450 and 550, because we have 50 less than 500 or 50 more than 500. So this is the interval we're looking for. That's the area, the probability we're looking for. So we want to take a look at the interval of 450 to 550. And again, on our calculator, same thing. 450, 550, and those would be all the values that are within 50 points away from our mean. And we get 0.3829. So the probability that a test score differs from the mean by less than 50 points is about 38%. Now we're looking kind of the opposite. Example 5 says, what's the probability of a test score differing from the mean by more than 75 points? So we want to go 75 points to the left, which is 425, and 75 points to the right, which is 575. And we're not looking inside that interval, we're looking outside that interval. Who's more than 75 points away? So we have to calculate the p for this interval and then subtract from 1 again. And so second vars, 425 to 575, and we get 0.5467. But remember, that's the probability of being inside the interval. We want outside that interval, so 1 minus 0.5467 is going to give us 0.4533, which means there's approximately a 45% chance the test score will differ from the mean by more than 75 points. All right, so all of these use the same function in our calculator, the normal CDF, and that we get from second vars, choice 2, normal CDF. This down here is going backwards. Here they're giving us the percentage, the probability, and we need to figure out what the value is. So example 6 says, what score is earned by the best 15% of test takers? So you figure it's going to be somewhere in here, and that's what we're looking for. So now when we go to second vars, it's choice 3, inverse norm, because we're doing the inverse. We're going backwards. So second vars, Miss Papa's laughing at me behind me. Choice 3, in the norm. And now let's see what info they want. So we go down to 3 and hit enter, or just hit 3. And they want the area. The area is the percent. But 15% of the best test takers is going to be the area to the right. So we actually want the area to the left. So you have to subtract that from 0.85. So we're looking for where 85% of the data is. Wherever that value is, the top 15% are to the right of it. So Area is 0.85. Mu is our mean, and that was 500. Standard deviation, sigma 100. Enter, enter, enter. And we get 603.6, so I would say about 604. So what that means is the top 15% of test takers are in this area here. That's that. We are going to do more problems like this together on Monday, so you'll get lots of practice of this, and have a great weekend. Thanks.